All right. So I want to talk about pattern matching in Elixir, since this is one of my favorite features. I'm Wojtek, by the way, and I work for Stack Builders. And so, as an example of pattern matching, I want to show you a game of cards, a simple game of cards. So this is Ace of Spades, and we can, so that's we can represent that as a string. We can get out a bit fancy, since all Elixir strings are UTF-8 strings. This can actually work as well, but it's not very useful representation. So this is how we want to represent that as a tuple. The card in the program. So we have a tuple of two elements. The first one is the rank, it's ace, and then the second element is the suit, which is spades. With this we can have, it kind of fits. We can have another data structure, which is a hand. In this case, it's a hand from Texas Hold'em. So we have two pairs. We have aces and sixes. And we can represent that as a tuple of cards. It's a tuple of tuples. In Texas Hold'em, we have 9 different ranks that a hand can be. So we have things like full house, flush, straight, two pairs, and so on. And now we want to have a program to figure out the rank for a given hand. In imperative programming languages, you can have this, bunch of conditionals. 90% of audience should recognize this code. You can, of course, move this out to methods, but it's essentially the same thing. And I want to show you how you can solve the same problem with pattern matching. So you all know that. That's a case expression. We have the pattern on the left and then the result on the right of the pattern. So in our example, we match the hand against these patterns. These patterns are the 5 card tuples. Sometimes we may not care about particular cards, so we can just put an underscore. Underscore is going to match any card on that particular slot. So, and then in pattern matching, you can go kind of further and sort of drill down into your data structure. So we can decompose or destructure each card into the rank and the suit part of it. So with all of these sort of theory behind this, this is how you can actually get this to work. So in this case, we have a tuple, and we match the first 4 cards, and we say that, the rank of all of these 4 cards must be the same. The suit doesn't matter, and then the 5th card doesn't matter. If your hand matches this pattern, you have a 4 of a kind. Another example is full house. So the first 3 cards must have the same rank, and then the last 2 cards must also have the same rank, but these are kind of 2 different ranks, right? And so with full house, we have something like aces full of kings, so 3 aces and 2 kings. And then finally, we have an example of a flush. So in flush is like any 5 cards. The rank can be anything as long as the suit is the same. And so to me, I find this much more readable. I can sort of visualize, I can see the shape of the data. And to me, I can just look at it and see that it's correct. It's also more powerful. So we can, this kind of bindings on the left, you can use them on the right. So it's more powerful. You can have more expressiveness there. So there's one caveat with this, is that straights, which is like 5 consecutive cards, are really tricky to do. And I actually don't know how to do them. So hit me up later. But in any case, that's all I got. Thanks a lot.